by animals to increase as well. This is sort of a lot of ecology and conservation biology and management, etc. I think what becomes difficult is figuring out what contributes to the quality of that. There are obviously many factors, but two very significant ones that have been addressed in detail through classic theoretical and applied studies are food and safety. Even when we limit habitat quality to two broad qualities, though, or categories, we still have to assess those categories. And I think intuitively we understand that not all food and safety are created equal. So the next question becomes, how do we assess the quality of those habitat characteristics? When it comes to food resources, a traditional way of doing so is just by measuring food availability across landscapes. In terms of safety, we often do the same thing. We look at the percent vegetation cover across various spatial scales. Those could be at a very small scale using line point intercepts all the way up to remote sensing across landscapes. I think what becomes difficult is when we realize that the presence or absence of a certain habitat characteristic isn't necessarily enough to explain patterns of animal behavior that we observe. So Graham Fry, who many of you know, demonstrated that sage-grouse are selecting black sage more frequently than we would expect based solely on its distribution across the landscape. And then similarly, Peter Olsoy showed that the exact same habitat, which is represented in these three panels, can actually offer very different levels of concealment from predators based on the perspective of that predator. So now we start to refine our questions and we ask, what functions do habitats serve that animals use to assess their quality? What are the functional qualities of a habitat? Based on the work of a lot of other people, some of whom are in this room, we decided to focus our investigation on 4 habitat parameters that we think are likely to represent functional quality for a small specialist herbivore. Under the food umbrella, we're going to look at plant secondary metabolites, and for the sake of simplicity, I'll just be referring to those as toxins throughout the talk, as well as the nutrition of those food resources. For safety, we're going to be looking at the concealment that those resources provide, maybe the opportunities to hide from predators, as well as the proximity to refuge in which they can escape potential threats. And I think it's important to note that a lot of these studies that we use to undergird our investigation, not all, but many looked at these parameters individually. So when we consider them individually, we can predict maybe how they'll influence patterns of animal use. I think it's intuitive to say that an increase in dietary toxins may lead to a decrease in overall habitat use, and likewise an increase in available concealment may lead to an increase in habitat use. Unfortunately, when we're trying to measure these in the real world, we come across the problem that habitats are heterogeneous. They're not all the same. And even something as seemingly uniform as the sagebrush steppe actually has incredible diversity when you start to dig down into these individual habitat quality parameters. What that means for an herbivore is that you have to make trade-offs when you're choosing where to spend your time. There's no such thing as the perfect plant that solves every problem you have as an herbivore. There's nothing that tastes great, is good for you, is perfectly safe, and is equally suited for finding a meal, resting, or potentially finding a mate. So when we considered all of these potential trade-offs that mammalian herbivores have to make in selecting habitat, we came up with 4 questions to sort of guide our study. And the first is, do multiple quality parameters combine to best predict use in certain habitats? That is, do these individual components of habitat function that we've identified work together to influence an animal's perception of that habitat? The second question is, do the parameters that best predict use change when you're comparing different habitat patches that may have different characteristics? As we mentioned, even something like the sagebrush steppe is heterogeneous, and different patches may be evaluated based on different criteria. The third is, do those parameters that predict use change based on what an animal's doing in a given habitat? An animal may select one habitat for foraging and another for mate selection, and we're curious if they're making separate trade-offs based on their intended use. And then finally, are animals making even more fine-scale trade-offs within what could be complex habitat parameters themselves? So some of these things are incredibly complex combinations that we've sort of simplified into an individual habitat parameter. And we think that it's important to understand and describe the trade-offs that may be happening within them as well. So given all of this complexity in evaluating habitats, what resources do we need to try and start answering some of these questions? The first is we need a habitat in which we can actually assess and quantify and measure the functional parameters that we've identified as potentially influencing use. We also, for our purposes, need an herbivore that assesses those same parameters and selects habitats for different purposes based on what it finds. And we think that the pygmy rabbit and sagebrush steppe system is really an ideal one in which to start getting at some of these complex trade-offs. The first thing is that despite all of the multiple parameters we're looking at, overall it's a relatively simple system. It's dominated by a single plant species, and we know that that plant species varies in the parameters that we're interested in. We also have an herbivore that inhabits that ecosystem, that habitat, and it relies almost exclusively on that single plant species. So pygmy rabbits in the wintertime eat almost exclusively sagebrush, and they're known from other studies to be sensitive to things like toxins and nutrients. Almost everything in the sagebrush likes to eat pygmy rabbits, so we also know that they're sensitive to predation risk. And finally, they're active around these central burrow systems, and those represent distinct habitat types within sagebrush habitat as a whole, as well as providing refuge from predators. And then finally, in the wintertime in particular, pygmy rabbits are using their habitat for essentially two purposes: finding food and not getting eaten. And we're able to identify evidence of these two different types of habitat use and distinguish between them in the form of bite marks and fecal pellets, which I'll discuss in a bit. So in looking at the four questions that we developed, the first three we decided to head to the field to try and address them. And in so doing, we identified, within this heterogeneous habitat, we identified small mounds, mima mounds, that are characterized by loose soil, denser and often taller vegetation, and it's these locations in which pygmy rabbits tend to excavate their burrows and spend a significant amount of time. So we identified and tagged 9 plants at 20 different mounds, and had a total of 180 on-mound plants. And then in those intermound areas, the vegetation tends to be sparser, the soil a bit denser, vegetation is often lower as well. So we established 20 off-mound patches in close proximity to the on-mound with 12 plants at each. To look at the quality parameters that we're interested in, we decided to focus in on monoterpenes, which is a class of volatile oils they're known to have deleterious effects on herbivores that consume them. So we identified and we quantified these monoterpenes using headspace gas chromatography. For nutrition, we looked at crude protein, which has also been shown to be important to foraging herbivores, and we quantified that using combustion analysis with the help of a forage lab in New York. For concealment, we focused on aerial concealment, and we quantified aerial concealment by taking approximately pygmy rabbit-sized cover boards and placing them at the base of each plant, taking a digital photograph from above, and then using superimposed grids to come up with an average % concealment available at each plant. And finally, at our field site, we conducted a comprehensive burrow survey. So we located every active open burrow entrance and measured the distance from each plant to the nearest active and open burrow. For use, at each plant, we looked for those characteristic pygmy rabbit bite marks that indicated the presence of foraging, and we looked for fresh fecal pellets that had that had been deposited during our study year for evidence of resting. Now, when it came time to start analyzing all of the data that we collected, we considered each toxin that we identified through our gas chromatography analysis, along with protein, concealment, and distance to refuge as individual predictor variables. After we removed any correlated variables that we had, we assigned each of them to a quality parameter, which then in turn belonged to one of those larger habitat features. And I'll note quickly that we separated in toxins and nutritions because there have been some previous studies from folks here that have already shown animals making complex trade-offs between those two. Next, we used a two-step model selection process. The first step was to create logistic regression models with binary, the odds of binary use categories as our response variables, and then those would be predicted by all possible combinations of variables within those specific quality parameters. So they were first separated by toxins, nutrition, and safety. We evaluated and ranked those models using an information theoretic approach, and we chose to consider models with delta AIC less than 2.0 that also performed better than an intercept-only null model as potentially informative models. We discarded the others. In the second step, we took the variables from those top performing models in the first step, included them in global models, and utilized the ranking process again. We also analyzed each use type, presence or absence of foraging, resting, or either, any use, within our different patch categories, as well as all plants analyzed together. Finally, we did calculate model average parameter estimates and confidence intervals. So in addressing our questions, first one, do these combinations of parameters best predict overall use? When we look at undifferentiated use of plants, any use, we find that top models contain toxin variables, nutrition variables, and safety variables. So we think that suggests a few things. Number one, we think that it reinforces the relationships that previous investigators have documented between those individual parameters and use. We think it's additional evidence that they matter. We've also built on some work of Jen's former students and others who've shown that there are interactions between these sorts of quality parameters. Looking back again at Graham Fry's work, he showed that grouse selection was predicted not by either nutrition or toxins individually, but by a complex interaction between the two. We think we support that and maybe go a step further in suggesting that safety is a predictor as well. And finally, we think that these results support our contention that the presence or absence of habitat features like food and safety are not necessarily sufficient to assess the quality of a habitat. And if we're going to understand how animals select habitat, we need to measure those functional parameters as well. Our second question, does the type of habitat patch affect which parameters best predict use? Again, going back to the tables, apologies. We found that location, which is representative of patch type, included as a significant variable in top models for all three types of our use. That would be undifferentiated use, foraging, and resting. So in considering these results, we think, we think that reinforces the idea that many of us find intuitive, that animals can tell the difference between heterogeneous habitat patches and the difference between them matters. Now, to figure out whether or not animals are actually evaluating them using different criteria, we need to look at the patch types separately. So when we go back to undifferentiated use, we can see that on-mound plants are evaluated using a single toxin variable. Additionally, the confidence intervals for this particular toxin variables overlap 1, suggesting that this might not even be a significant variable in terms of predicting changes in use. By contrast, when we look at off-mound undifferentiated use, that seems to be driven by a combination of parameters. Again, we have nutrition and distance from burrow both being significant predictors, and we've got some potentially insignificant toxin variables as well. That's exactly sort of what we would expect from a central place forager. So there are plenty of classic studies that suggest animals who are tied to a central place should only venture further from their refuge or that central place if they can expect to gain more from the resources they encounter there than they would closer to their refuge. They'd need to make up that difference that they would experience in increased predation risk or travel time. When we look at only used patches, however, we find that the off-mound used patches are actually of lower quality as defined by their crude protein concentrations, by their 1,8 cineol concentrations, which you may recall was the top toxin variable that appeared in models, as well as aerial concealment. So we think it's unlikely that pygmy rabbits are traveling farther from their burrows and farther from their refuge just for the chance to use lower quality habitat. So we think that these results suggest something else is driving pygmy rabbit movement. As we said before, these are patchy habitats. There's significant heterogeneity. So it could be that they're moving between high quality foraging patches. To start addressing that, these are just some initial analyses we've done. We averaged both the quality and use parameters across patches instead of at an individual plant scale. And those results suggest that toxins and nutrition may influence selection at this larger scale as well. This idea of patch scale selection and larger scale selection, which has been addressed in grouse and some other animals, we think is potentially very interesting and a really promising direction for further work. And we've got some folks who are looking at that as well. I think another interesting aspect of pygmy rabbit ecology in general is that the movement patterns of pygmy rabbits are largely unknown. There are these huge variations in ranges, in home range estimates, along with significant differences between the sexes and the seasons in which those rabbits are moving. And we think our results underline the idea that we need to learn more about movement patterns. Hopefully we'll get there with some telemetry and GPS studies. Our third question was, do animals use different criteria to select habitats that they're going to use for different purposes? When we look at foraging, we see that patch type location still matters, but that other safety variables drop out of the top models and they leave predominantly toxins and nutrition as predictors of foraging. When we look at resting, we still get that single toxin, but we also get two safety variables now, with parameter estimates that very narrowly overlap one in this case. And if we start looking at patch types individually, we even get a bit more complexity. So in this case, looking at on-mound foraging behavior, we still have that single toxin variable with insignificant parameter estimates. That could mean that all on-mound plants are sort of created equal, and that pygmy rabbits are not differentiating between them or choosing randomly. But we think it could also mean that there are parameters that we haven't measured that could be affecting use. There could be other spatial characteristics, or there could be toxins that have fallen out of our analyses based on correlations, or potentially mixtures of toxins that have synergistic effects. And that's something I'll come back to. By contrast, when we look at off-mound foraging, that seems to be strongly driven by nutrition. Off-mound resting, likewise, is significantly driven by proximity to a burrow. So given what we now know about the relative quality between those on and off-mound plants, we think this could mean that when pygmy rabbits do move off of their mounds and move into these lower quality habitat patches, they may be forced to seek out the very best of what's available out there. And that's significant. Again, focusing on pygmy rabbit ecology for a moment, most work has been done, is focused on these burrow systems and these central places. If they are forced to travel between them with any sort of frequency, whether that's to find other burrows or to find foraging patches or during the mating season, the quality of that habitat in between high quality patches could be incredibly important. Expanding out to other systems and other organisms, I think that this also has some repercussions. We often strive to sort of minimize our disturbances to wildlife by designating and avoiding critical habitats, like mounds and burrows in the case of pygmy rabbits. If we can sort of better understand the trade-offs animals are forced to make when they do choose different patches, we may be able to better identify previously overlooked areas of importance and maybe plan our infrastructure or our conservation efforts more effectively. For our final question, we wanted to look a little more closely at one complex quality parameter and figure out if animals were making trade-offs within it. So I think anyone who's been to Dr. Forby or her students' talks are probably aware that sagebrush toxins are an incredibly complex source of interest. The amounts and concentrations of toxins can vary significantly. They can vary among taxa, they can vary among different populations, and they can vary even among individual plants. So our earlier efforts that I've just sort of described, they suggest that these toxins do indeed influence habitat use in some situations, but we're forced to simplify them into a sort of monolithic quality parameter. And like most fieldwork, our results were correlative. We're also interested in the mechanism of how these different parameters affect animals. So many of us know when it comes to the mechanistic effects of toxins, there are a couple of things that could be in play. One is the dose. More toxin generally leads to greater effect. In addition to dose, there are mixtures, though. Combining different toxins could produce different physiological outcomes than consuming a single toxin, even if it's at the same concentration. So to try to address which of these mechanisms may be driving pygmy rabbit responses to toxins, we identified the top 5 most common monoterpenes in whole sagebrush, and we basically built a simplified sagebrush cocktail. We mixed them together in the same average proportions in which they're found in whole plants, so that this toxin cocktail is roughly representative of whole sagebrush plants. At Washington State, we then conducted choice trials in which we offered captive animals a choice between the mixture of toxins and a single constituent compound. So each choice was treated with the same concentration by weight. So you'll notice that regardless of what an animal chose, it was still consuming the same overall concentrations of toxins. In this case, the blue represents alpha-pinene as the single constituent, and then on the left you see the mixture. And we repeated that process for all 5 constituent compounds. So here's what we found. When we look at this figure, by the way, the y-axis represents the proportion of total intake that consisted of the mixture or the toxin cocktail. So bars that appear above the dotted red line represent a preference by the animal for the mixture compared to the single toxin. And bars below the 50% line represent a preference for the single toxin. So in this case, comparing alpha-pinene to the mixture showed that pygmy rabbits didn't have a clear or at least a statistically significant preference either for or against alpha-pinene compared to the mixture. When we look at all 5 together, I think one of the interesting points is that pygmy rabbits had no significant preference for or against 3 out of the 5 toxins that were offered in combination with the mixture. So in these 3 cases, that could simply be a result of an insufficient dose for the pygmy rabbits to be concerned with. Recall that our treatments were only 1% by weight, and this is at the low end of monoterpene concentrations found naturally in sagebrush. Additionally, 1% is significantly lower than the concentration at which a single compound in a previous captive trial led to notable decreases in pygmy rabbit food intake. So if we were able to increase the dose, we may see preferences emerge, but at 1%, we think this could be a function of dose. When we go back to our overall results, we find that there are 2 compounds that did elicit a preference, and I think it's interesting to note that pygmy rabbits actually preferred the single toxin to the mixture in these cases. So if you go back to our toxin cocktail versus the single toxin, you'll recall they were offered at the same concentration. So by choosing the single toxin, pygmy rabbits are essentially choosing a higher dose of that toxin than they would be if they were consuming the mixture. We think that means that dose may not be the driving mechanism in those cases, and instead it could be the synergistic effects of consuming mixed toxins. I think this is old hat to anyone who spends time reading the pharmaceutical literature, as well as maybe some people who do recreational research. But this is a relatively new field of inquiry for ecology and herbivore-plant interactions. There are a handful of studies that have shown, however, that consuming these complex mixtures of toxins have a greater negative effect. Do recreational research, but this is a relatively new field of inquiry for ecology and herbivore-plant interactions. There are a handful of studies that have shown, however, that consuming these complex mixtures of toxins have a greater negative effect. Do recreational research, but this is a relatively new field of inquiry for ecology and herbivore-plant interactions. There are a handful of studies that have shown, however, that consuming these complex mixtures of toxins have a greater negative effect. Do recreational research, but this is a relatively new field of inquiry for ecology and herbivore-plant interactions. There are a handful of studies that have shown, however, that consuming these complex mixtures of toxins have a greater negative effect. Do recreational research, but this is a relatively new field of inquiry for ecology and herbivore-plant interactions. There are a handful of studies that have shown, however, that consuming these complex mixtures of toxins have a greater negative effect. Do recreational research, but this is a relatively new field of inquiry for ecology and herbivore-plant interactions. There are a handful of studies that have shown, however, that consuming these complex mixtures of toxins have a greater negative effect. Do recreational research, but this is a relatively new field of inquiry for ecology and herbivore-plant interactions. There are a handful of studies that have shown, however, that consuming these complex mixtures of toxins have a greater negative effect. Do recreational research, but this is a relatively new field of inquiry for ecology and herbivore-plant interactions. There are a handful of studies that have shown, however, that consuming these complex mixtures of toxins have a greater negative effect. Do recreational research, but this is a relatively new field of inquiry for ecology and herbivore-plant interactions. There are a handful of studies that have shown, however, that consuming these complex mixtures of toxins have a greater negative effect. Do recreational research, but this is a relatively new field of inquiry for ecology and herbivore-plant interactions. There are a handful of studies that have shown, however, opportunity to measure these parameters using new technology. We've had some initial success with near-infrared spectroscopy. Peter also, as I mentioned before, is doing some great work currently to help us quantify parameters of interest like toxins, like nutrition, like even the palatability of plants in the field, in situ, without having to collect samples and do wet chemistry in the lab. We also have the potential to use LiDAR and other 3D remote sensing techniques to map and quantify not just the percent cover or the distribution of resources, but functional qualities like concealment provided or the visibility that an animal in any one given place has. And then by taking these sort of expanded, these new sensors and technologies and combining them with things like unmanned aerial systems and remote sensing technology, we might be able to actually map those things not at individual plants or patches, but across landscape scale habitats. Finally, we can continue to do what we're doing and go out and collect and assess these habitat parameters that we think are important to animals. We can combine them into predictive models that predict use based on those parameters and represent the functional quality of a habitat, and we can test and validate them. We have multiple sites at which we're trying to continue this work. We're doing it at different spatial scales, we're doing it in different seasons, and we're expanding it to different organisms and different species. So by doing all of that, I think we can eventually go beyond measuring whether habitat is present or not, which is important work, but we can take further steps and we can start to see the landscape through the eyes of the animals that we hope to understand and manage. And if we're going to do so effectively, we really need to put ourselves sort of in their shoes and continue to explore. So I won't go through all of them, but briefly, while I have your attention, I do want to throw out many thanks to folks who've helped me along the way. My committee members have been fantastic. Jen is one of the more patient people I've ever met, and Lisa has helped me in everything and made it all the way down, and Mariana has given me many new things. frameworks in which to think about my work. So thank you to them and the countless people who've helped me along the way. Thanks. Half hour.
Yeah, go ahead.